Hello and welcome to the third weather briefing for Eyes to the Sky Environmental Services. I'm meteorologist Chris Lasakis. I would like to talk to you this evening about the threat for severe thunderstorms and possibly even a few tornadoes coming up on Thursday of this week. I say that specifically because we're looking to possibly engage in our third Intensive Operation Period, or IOP, for the VORTEX Southeast program. A field campaign coming up on Thursday, and currently we are scheduled for an IOP this Thursday, but that can be taken aback at any time or canceled at any time between now and then. So we're going to be watching it, and we're going to look at some interesting charts here in just a moment and focus again on that threat for severe storms for Thursday in hopes that maybe we can get it figured out and try to understand exactly what the atmosphere might have in store for us down the road here this week. So looking ahead at our first slide here, I want to bring this up because this is something that we're dealing with because of El Nino. And as El Nino continues to deteriorate as we head into spring, we're left with this subtropical jet stream that's flaring up as we get upper level contrasts and temperatures that have resulted from lower level sea surface temperature differences in the northern hemisphere due to El Nino. And as this subtropical jet stream that you see right in through here, the brighter colors, interacts with incoming waves in the atmosphere, you can see one of them right here, this horseshoe shaped trough. Sometimes in El Nino springs, or springs where you're coming out of an El Nino pattern, you can have enhanced areas of severe storms that develop between the subtropical jet stream, which is this here, and what we call the polar jet, or the frontal jet, which would be right in through here. And so we're going to have to watch for that this week as we head into the first potential significant threat for severe thunderstorms, I feel, this spring. Possibly the best chance of severe storms here since December 23rd of 2015, when we were under an enhanced risk for severe storms here in North Alabama. So keep this subtropical jet stream in mind as we look forward into the future slides. But one thing that's interesting that I want to point out is we are going to be in the Tennessee Valley right on the nose of this subtropical jet stream. You know, the jet stream is right, this is known right here as the entrance region, this is the exit region. And some meteorologists like to pay attention to what we know as the left exit region, the right exit region, and left entrance, right entrance. I do put some weight in that when considering the threat for severe storms and progressing storm systems with time. But sometimes it's best just to look toward the front and back halves to have the jet stream and to bisect each one of those and diagnose the weather situation accordingly. So I like to look at the nose of the jet stream, which is right in through here, especially if the subtropical jet, like here, is nosing into the threat area. This area right in here would certainly be an area of interest from western Mississippi through the northwest corner of Alabama, right in through here. So keep that in mind as we move forward. And you can see that subtropical jet is really cranking. That's an area of 140 knots of wind right in through there through central Texas, North Louisiana, and even getting into the 120 knot range into western Mississippi. So that is not a weak upper level jet. That's up there at about 35,000 feet is where this particular jet is going to be located. Forecast, this plot is for 4 p.m. on Thursday. So I need to make sure that I definitely state that. Going ahead here, I want to look down a little bit lower. This is the 500 millibar wind plot. And again, keep that jet streak, that subtropical nose area in mind. I know that's kind of a funny sounding term, but that's what a lot of us refer to it as here in the meteorological community. We refer to it as the nose of the jet streak. And so now looking down, 500 millibars is about 18,000 feet now. So we've come down in the atmosphere. And you can still see some hints of a subtropical jet, not as much though, because we've moved down in the atmosphere. But more so what we're seeing is this trough. And you have this intense trough here that is beginning to move up the eastern side of the trough. It's what we call a lifting system. But the interesting thing to note here is the close proximity of the fastest winds to that area that I pointed out, Mississippi and northwestern Alabama. There's even something, what I like to refer to as a height discontinuity. Right here you have these equally spaced lines, and then all of a sudden you have this gap right in through here. Well, just to this side of that gap, right in through here, there tends to be severe storms that can develop associated with circulations, frontal circulations, ageostrophic circulations that can develop just past those height discontinuity lines if given an ample parameter space, such as favorable instability in the atmosphere, etc. So we'll go into that, but I do want you to note this 500 millibar jet streak associated with the trough in relation to the subtropical jet. That's important. Okay, now going down even further, this is the wind forecast for 850 millibars, or about 4,000 to 4,500 feet up. We have pretty strong winds here too. Not the strongest I've ever seen, but definitely sufficient across northern and northwestern Alabama. Again, for some severe storms, maybe northwest Tennessee, western Tennessee as well. So right in through here would probably be the greatest threat for storms at this time. Maybe broaden it out, maybe something more like about like this right in through here. And we'll have to watch that. But I do want you to notice this though, the 850 millibar jet. This is important for bringing moisture up and increasing the low-level shear. You get that strong southerly flow off the Gulf of Mexico into this area here, northern Alabama. And at the same time, that strong low-level wind flow, this is forecast to be about 45 knots over north central Alabama. Again, this is for 4 p.m. All these maps are going to be for 4 p.m. on Thursday, helping to increase the low-level wind shear. So keep that in mind. So we have the lift from the upper level jet and the subtropical jet, and then we have the instability probably coming in from the Gulf because we have southerly flow here at the 850 millibar level, helping to usher in instability. We have relatively cool air aloft, higher in the atmosphere than even this. So all that's adding up to some unstable air. This is the dew point forecast, again for 4 p.m. Thursday. You can see there's some pockets here of 70-degree dew points. Now, the NAM model is known possibly to overestimate dew points maybe a little bit. You know, sometimes it can vary even a lot. It just depends on the particular run and which version of the NAM you use. But I would tend to believe this. At least 65-degree dew points here on Thursday, which is more than favorable for severe thunderstorms and even tornadic weather. So we'll have to keep an eye on that for sure. You can see the area of surface low pressure is up here across the eastern Corn Belt, parts of Illinois and Indiana. Looks like it's centered there just to the west of Indianapolis, Indiana. Again at 4 p.m. Thursday, and you can see the strong southerly level flow, southerly low level flow off the Gulf. Excuse me. What's really interesting too here is this frontal system. You can see the kinking in the isobars right through here, indicating the placement of the front, the surface cold front. Right in through here. That's going to be very interesting as we look at something known as the deep wind shear vector here in just a moment. Keep that tilt in mind right here as we look ahead. But so basically the takeaway message is for this particular plot, we're going to have strong low-level wind flow and sufficient or at least modest low-level wind flow. I don't want to say strong because it may not be strong. It might just be, you know, sufficient or ample, modest. And you can see that coming out of the south. And we have sufficient moisture, more than sufficient moisture for severe thunderstorms. So keep those in mind. Right here I want to talk a little bit about something called theta E. These bottom plots are theta E, which is a composite parameter that combines moisture instability and instability. We look at this primarily to try to figure out locations of fronts, the areas of burst point for convection, when we're looking for the location where thunderstorms might grow later in a forecast. We can use this to determine the areas of maximum buoyancy in the atmosphere. And if we look at, I believe this is a 925 millibar plot. I think it got cut off here when I was building the image. plot, but I think it got cut off. This is 925, and something interesting to note here is we have two surges of theta E. You can see one area coming up here of the higher values. You can see here's a value chart right here to help you gauge the intensity. The brighter reds are the higher values, and as you move down to the cooler ones, you get less and less theta E. So here is a 1 theta E ridge. Looks like that's pushing about 325 Kelvin values of theta E, and then you get this secondary surge right in through here across eastern and central Alabama up into eastern and central Kentucky. That's telling me that potentially we're going to have what's known as a prefrontal trough that's going to come through here on the day on Thursday. Now that's going to play a very big part in this as well, because thunderstorms, especially severe storms, or really any storms in general, I'll just generalize it first, like to form on prefrontal troughs. It's an axis of convergence and forcing in the lower levels of the atmosphere, and you get thunderstorm precipitation growth along that prefrontal trough that can tap some instability and wind shear that may be out ahead of the cold front. If you have what's known as an inactive cold front, where the wind vectors, the deep wind shear vectors, are oriented perpendicular to that front, typically you won't have a whole lot of activity on that cold front, and everything will be out ahead of the cold front in an inactive front. An active front would be different, it'd be opposite. And you would actually have development of convection along the front primarily. That would be an active front. Now, if we look over here to the right, on the bottom right, this is at 850 millibars, and we can see that there's also evidence of that prefrontal trough showing up here very well from southern Alabama all the way up into Tennessee, and then, of course, along the cold front back here and along the Mississippi River Valley. And I stuck these vertical velocity plots up here. These lines, the iso height lines, I want to point something out. I mentioned about height discontinuities a minute ago, and about how thunderstorms like to form just to the east or south of those. Well, you can see here at the 700 millibar, you can see the labeling, 700 millibars there. We have even spread of the height contours here, here, and then all of a sudden we get this wider gap right in through here. And where that, going down to the bottom plots, where this prefrontal trough, which is going to be right in through here, through north central Alabama, where that intersects that height discontinuity, that gap, that's typically where you're going to find your strongest storms, is some research I'm doing. And that appears to be the case here, potentially. And there's some other maps that by copyright I'm not allowed to show, but I wish I could, but I can't do that. But they indicate very strongly that there's going to be streaking of the precipitation across north and central Alabama on the day Thursday, from the European model particularly showing this. That would seem to indicate supercell convection during the day here on Thursday, which could increase chance for severe weather and even potential for tornadoes. You can also see that height discontinuity on the 500 millibar plot right here. Well, let me go back for just a sec. You can see an even gap here, 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 and then you get this wide gap right in through here. And remember, their prefrontal trough is right in through here, and so we can expect potentially some severe storms right in through here across North Alabama and South Tennessee as a result. It kind of helps zoom in on the area of threat. This is instability or buoyancy map known as CAPE, convectively available potential energy. It basically helps us give a first order approximation as to how buoyant the atmosphere could potentially be. And there's a lot of caveats to this, folks, a lot of things that can detract from this or even add to it. So this is just, like I said, a first order approximation of the instability. And excuse me, if this is accurate, we're going to be very unstable during the day here on Thursday. CAPE values, as you can see in the legend over here on the left, approaching 2,000 joules per kilogram. That is very buoyant, and definitely will add fuel for thunderstorms. And again, there's some signs of that prefrontal trough. You can see this surge in CAPE right through here, where you have these greens, and then you have a gap of lesser values. It would seem to me as if there's going to be a prefrontal trough boundary right in through here at 4 p.m. on Thursday. somewhere, roughly from Huntsville to Birmingham. But that could potentially change, and probably will. I mean, the models, we're going to flip-flop some between now and then. This is something I like to look at called the Supercell Composite Index. I was going to show you the significant tornado parameter, but in place of that I chose this because I really don't want to jump the gun on the tornado threat quite yet, because we're still 3.5 days out from this thing. So I really don't want to go there yet. But this will give you a first order approximation that there are supercells possible. And of course, supercells, you all have heard that term. That's something we have to monitor for tornadoes. So we'll keep an eye on that. But the values obviously are maxed out, or the highest on this chart. I don't want to say maxed out really, because this is the scale you can see. But the values do creep up there, but somewhere between 10 and 12 on the day on Thursday. Looking at a SKU-T now for 4 p.m. on Thursday, you can see the wind shear profiles are favorable for severe storms. They're not overly strong, but sometimes it's all about the ratio of cape to wind shear, or buoyancy to wind shear. And so the low-level turning here is existent, it's just not really strong. Our 0 through 3 kilometer storm relative helicity is right at 300, which is definitely sufficient for rotating storms. So we'll have to keep an eye on that. The significant tornado parameter, again, is on up there ways, suggesting tornado potential. The deep shear vectors are going to be oriented mostly out of the west-southwest, given how the wind profiles are distributed here. The surface through 8 kilometers storm or bulk shear is going to be 43 knots at surface through 8. That's a little on the low side. But surface through 6 is 50 knots, so we'll have to watch that, but that's still sufficient for thunderstorms for sure, and severe storms at that. So we'll go ahead. This is something that I like to look at when trying to ascertain the overall tornado potential or severe storm potential for an event. If I want to try to determine the ceiling, if you will, how high an event could potentially go, looking at old events and comparing them to what the models are saying could happen with this system. And what I'm seeing is, this is from St. Louis, Missouri, and the analogs that are coming out, or the comparisons that are coming out now for this event Thursday, gotta admit, they're a little concerning. It doesn't necessarily mean this is what's going to happen, but it means it's possible that we could have definitely tornadoes here. Looking at the top analog, this is from the 11th of April, 2008, when we had tornadoes across North Alabama and southern Tennessee. There was an F3 tornado near Lawrenceburg, Tennessee, and some weaker tornadoes across north central Alabama. But the main supercell tracked right through here across southern middle Tennessee. The second analog is from the 16th of April, 1998. Now, this analog is certainly much more concerning, because Nashville had 3 tornadoes pass through Davidson County that afternoon. Several very damaging tornadoes, F3s, F2 and F3s, went through downtown Nashville. And F5 actually went through Deerfield in Lawrence County, Tennessee. Wayne and Lawrence County, Tennessee there. This one right through here. So that's another concerning day that's being compared to what could happen Thursday. Again, this is not set in stone. I want to make sure that I really stress that. This is the 2nd of March, 2012, the one here in the lower left. And basically what happened on this day is it was a large-scale tornado outbreak across parts of the Ohio and Tennessee valleys. A tornado passed near Anderson Hills that day, an EF3, and then larger tornadoes across southern Indiana where they had an EF4 near Henryville. So a very active day indeed. And then this one, I can't remember the date from this one. I think it was back in 1980. But you can see a smattering of tornadoes on this day too, as well as damaging wind reports in blue and hail reports in green. So quite a comparison for the event coming up on Thursday. We have quite a few comparisons, analogs that would suggest tornadoes are going to potentially happen. This is something called the CFS chart. This is produced by the Storm Prediction Center in Norman, Oklahoma. Over here on the left are what we like to call, in mathematical terms, the ordinate. This is the date that the forecast was produced. So today, being the 28th of March, we'll look at this top line right through here on this ordinate portion of the graph right through here. And then on the abscissa, which is the bottom, or the x-axis as you may know it, y-axis, x-axis, this is the date for which it is forecasted for. So we have forecasted on the 28th of March, forecasted for the 31st, 30th and 31st, looks like mostly the 31st, which is this line here, a threat of severe storms. The brighter values are the higher threat. Here's the legend. So you can see where those all intersect. Forecast for Thursday. Definitely a threat for severe storms, and that's been in the cards for quite a while now. If you look down again on the y-axis, looks like they've been calling for that since the 22nd, so almost a week now. That's a lot of consistency, got to tell you. So that definitely suggests that we're going to have severe storms here Thursday. So in summary, I want to wrap this up. There's a threat for severe thunderstorms Thursday afternoon and evening across the south. This does include north and central Alabama and southern middle Tennessee. North Mississippi is included as well, and also potentially western and northwest Georgia. Have to watch that, but right now the potential for the strongest activity looks to be across North Mississippi and northern Alabama and middle Tennessee. We'll know more about that tomorrow. The extent of the threat will hinge upon several factors that are not possible to resolve at this time. Weather model data is only so good, and it's gotten a lot better over the years, but there's a lot of mesoscale features or small-scale features that we can't resolve, like rain-cooled outflow boundaries, secondaries of surface low development, exactly how strong the jet stream is going to be, how much instability is going to be in the atmosphere affected by upstream convection or rain that can cool the atmosphere. There's a lot that we don't know about. Large hail, damaging winds, and tornadoes are all possible with this system. Don't want to rule anything out yet. And also at the same time, I really don't want to make this into too big of a deal yet. You have to leave some possibility for things to flop either way, because more than likely at some point they will. Instability appears sufficient for now. Lots of CAPE is forecast. The subtropical jet will likely play a significant part in the evolution of this system. This was one of the reasons why one of the top SIPS analogs picked up on April 16th, 1998, was that the subtropical jet was a very strong influence in that system as well. And the tornadoes happened between the subtropical jet and the frontal jet, or the upper tropospheric jet. And that's where the main tornado evolution occurred that day. So that's why that's appearing as an analog, and that will be a significant player in this system as well. I think I just went out of my PowerPoint there. Let me go back into this because there's more to talk about here. So getting back to that, the subtropical jet will play a significant evolution in this. Prefrontal trough is crucial. As previously mentioned, there's a hint that it's going to be there. Prefrontal troughs play a large role in southeastern tornado events. This has been written about in journal articles for years, that this is the case. And most big tornado events we have here in the southeast, you can partially attribute it to a prefrontal trough. That's where supercells love to form. Supercells really don't like cold fronts. You can get cold frontal rain band tornadoes along cold fronts. You can get, squall line tornadoes there. But typically, your strong tornadoes plus more greater intensity tend to favor the prefrontal troughs or dry lines, which occur further west typically. So prefrontal troughs are definitely of concern. Evolution of upstream convection will be important with this system. If we get a large area of rain along the Gulf Coast, there's been a lot of talk and rumor going around that this acts to cut off the moisture from the Gulf. I really don't feel that it cuts off the moisture, but what it helps to do is it helps to muck with the lapse rates in the atmosphere. It helps to reduce the instability from condensational warming due to precipitation and updrafts further to the south. that produce condensational warming and reduce the lapse rate in the atmosphere, as opposed to cutting off the surface moisture, or even 850 millibar moisture. So yeah, that's something I've been thinking about. It's a theoretical construct I'd like to work on when I have some time to really sit down and think more, but things have just been really busy. Okay, also the development of secondary surface low, this must be watched as well. This would increase the low-level wind shear and warm air advection or instability. We've seen this before, particularly there's one good case back on the 16th of December 2000, the Tuscaloosa F4 tornado, and also from April 28th, 2014, when we had a smattering of tornadoes across Dixie Alley that day. So a secondary surface low can greatly enhance the low-level shear and instability via low-level thermal advection. So you have to watch out for those. The model agreement isn't the best at this time with this system, but it isn't terrible either. And so we'll have to watch the evolution Tuesday, tomorrow, and Wednesday into early Thursday as well as we get closer to the event. But for now, I'm meteorologist Chris Lasakis for Eyes to the Sky Environmental Services. Y'all have a great evening.